Welcome back to another Inventor tutorial. In this tutorial we're going to look at constraints in more depth, specifically within the 2D sketch area, and look at how we can really control our 2D sketching using both dimensional constraints and physical constraints. So let's jump on in and see where we end up. So I'm going to start a 2D sketch, and for this tutorial I'm going to start it on one of the vertical planes. So I'm going to choose the XY plane. I'm going to start off by just doing and drawing some quite random lines. I've got a part in mind that hopefully should come more obvious as we go through the tutorial, but I want to show you the power of the constraints, both dimensional and physical. So I'm not really going to worry too much about this this drawing, because I'm going to actually use the constraints to constrain the drawing and then create the part by using almost the constraints. So I'm going to start off by just creating some relatively random, or what will look to be relatively random lines. So that will do for the moment, and I'll just close the drawing up. So it doesn't look like much at the moment, but what we'll do is we'll start to use our constraints to constrain the drawing into a two-dimensional drawing that we can then use to create a three-dimensional part. So the first thing I'm going to do is I'm going to make some of these lines horizontal and vertical, and we can use the horizontal and vertical constraints up here in the constraint tab. So I'll select the vertical constraint. I'm going to make this line vertical. I'm going to make this line vertical. I will then make these all vertical lines. And you can see Inventor immediately brings them into the vertical alignment. So I'm also going to make, I'm going to put a horizontal constraint in with this line here, which will also make this one horizontally constrained. So I'll come over, select my horizontal constraint, select the line, and you can see that's brought those two into being perpendicular to this vertical line. I'm also going to, I want to make this vertical line here that I'm highlighting green, and the one below it, I want them to be equal length. So I'm going to use the equals constraint, this tool here, and then come over and select those two vertical lines, and they are now equal to each other. The other thing is that I want these four lines that are horizontal all to be equal to each other. So I'll come across, select my equals constraint, and I'll select the first two. And then I'll come back and I'll select the original one again, and then I'll do the one below it, and then I'll do the same again for the one below that. So these three lines are linked to this top line here. That's all I need to do for this for the moment, because they're now going to do dimensional constraints. So we'll start off with our general dimensional constraint. Select the top line so that we can dimensionally constrain that one. I'm not going to change any of the measurements at this moment in time. And then working around the drawing, I'm going to select a few other dimensions that some of them are linked and some of them aren't linked to other areas. You'll find that if you do have a dimension that is linked to another dimension, that you'll get a warning come up. So this dimension here is obviously the same as this dimension here. So when I go to create that dimension, I'll get this box up here, which will say that it's over constrained. I can accept this warning, and then what I'll get is a driven dimension, which is basically a dimension in a box, but obviously it's driven off, in brackets, it's obviously driven off of this measurement here. So I'll just cancel that one. And of course this dimension here will be driven off of all of these dimensions, so I can cancel that. It's not fully constrained as yet, because we also need to constrain it around a particular axis or coordinate point. So what I'm going to do is I'm going to constrain the bottom point here to the origin here, and to do that I use my coincident constraint. So I'm just going to select this bottom point here and the origin, and you can actually see the outline has gone black all the way around, which tells you that it is fully constrained both dimensionally and physically. What I'll do now is I'll start changing some of these measurements into some more realistic figures. So for instance, I'll double click on this D0 dimension, and I'll set it to 20 mil. This dimension here I'll set to 3 mil. The indent dimension here I'll set to 5 mil. These two measurements, they're obviously linked together, I want to be the same, and I'll set them to 2 mil. This one is the separation between these two indentations. I'll set that again to 1.5 mil. And then this height from the bottom indent to the bottom of the actual part, I'm going to set to 50 mil. And now what I'm going to do is I'm going to finish this sketch. What I'll do now is I'm going to use the revolve function. So I'm going to come over and in the create panel I'm going to select revolve. It's already selected the profile, that's obviously highlighted. I'm then going to come down and I'm going to, it's already activated the axis to show which axis I want to revolve it around. So I'm going to select the long vertical line, and I've set the angle already predicts that you want to go 360 degrees. So I can click OK, and you can see we've basically been able to design a sort of piston or something similar to what would be a piston. Now the interesting thing here is that because it's fully constrained, if I then double click on this or open up the tree to show sketch 1, and I then double click on that, I come back to my two-dimensional drawing and I can adjust the dimensions and it will then update. So I can I'll make this 30 mil, which for the radius, which will give us 60 mil diameter, and then when I finish the sketch it updates, and obviously it's fully constrained, and it's updated the actual 3D model. Now these two grooves here are potentially where you might put rings, piston rings. If you want to change those, then again you can double click them, and actually you only have to change the two measurements here, and obviously the bottom piston ring will then update for there. So 5 mil is maybe too deep, so we'll go 3 mil, and we actually want to go with slightly thicker rings, so we'll go 2.5 mil, and you can see that they've updated, and now when I finish the sketch it will also update through to this particular drawing or this particular part. So that's how you do these constraints, physical and dimensional constraints. They really are useful in general modelling. It allows you to really have control of the drawing, so that if you do need to do any alterations or modifications, then of course that becomes quite simple for you. So that's it for this tutorial. Join me again soon for another couple of tutorials on Inventor.